Hello, I am one. Today's topic is the order of operations. It's also known to you as GEMDAS. Used to be called PEMDAS because the P stood for parentheses, but we've decided to really go a little bit further than just saying parentheses and say instead of the P, we use a G for grouping symbols. And so it goes this way now. The order of operations, the very first thing that you should do is the grouping symbols, then exponential expressions, followed by multiplication, then division, and addition and subtraction. So these are GEMDAS. So we wanted to make sure that you understood that grouping symbols, the reason why we're saying that instead of just parentheses is talking about angle brackets, braces, square brackets, all of that stuff is grouping symbols. But it also includes things like when you see a fraction and you see a sum or difference in that fraction, um, like for instance, A plus B over C. Well, the fraction bar itself is a grouping symbol, and so we also have to make sure that you do it that way. Another case might be, and I'll do this with numbers this time, 5 plus 3 divided by 3 plus 1. And that would be grouping symbols as well. The bar itself represents grouping symbols. 5 plus 3 is a group, and 3 plus 1 is a group. And this ends up being the same as saying 8 divided by 4, and that would equal 2. So those are some ways of thinking about it, and that's grouping symbols. The next to consider is exponents. So any expression that has an exponent denoting repeated multiplications, this must be executed after any grouping symbols have been resolved. So you know what exponents are. For instance, 2 to the third would be the same as saying 2 times 2 times 2, and that would be 8. So that's that's the next thing after grouping symbols. So grouping symbols, then exponents, then multiplication and division. And I like to say those together because there's multiplication and division being multiplication of the reciprocal. Now we'll get into that in a little bit, but we're talking about multiplication and division, and typically we go from left to right in the order that we see them in the expression, and then followed by addition and subtraction. So that's GEMDAS. You should always be thinking grouping, exponents, multiplication, division, addition, and then subtraction. And then finally, I wanted to just kind of add some extra thoughts to this. That subtraction, if you really think about the definition of subtraction, it's the addition of the opposite. Now, if you think about it that way, then it kind of takes out some of the confusions of some things. So, for instance, let's start off very simply. Subtraction is addition of the opposite. So if you had an expression like 7 minus 3, that's the same as saying 7 plus negative 3, because that's addition of the opposite of the second argument, which is 3. So the opposite of 3 is negative 3. So if I say 7 plus negative 3, well, that's a subtraction, and that's just 4. Well, that's pretty simple. But what if we were talking about an expression like this? 6 minus negative 4. Well, if you treat that as addition of the opposite, what is the opposite of negative 4? Well, this is the same as saying 6 plus the opposite, which is positive 4. And now you can say, oh, well, that's just addition of 6 and 4, so that's 10. So some people like to say it this way. If I said 6 minus negative 4, they go plus plus, and that's okay because it just solidifies the idea that this is addition of the opposite of negative 4, and that turns into 10. So you can do it that way, and that justifies the reason why we do that. So that helps us out. What if we had something like -6 minus -4? Now we're getting into, okay, this is the same as saying -6 plus 4, because we're saying plus plus, right? Well, now you say, all right, we're adding two different numbers with different signs. We subtract and then give the answer, the sign of the answer, what was the larger number. Well, the larger number is -6. I subtract 4 from 6 is 2, but the answer is -2 because the 6 was negative. So I hope that helps in that situation. The next thing to talk about is the fact that division is multiplication of the reciprocal. So if you're thinking of division, so think about it this way: multiplication of the reciprocal. For instance, if I was to say divide 12 and 4, well, this is the same as saying 12 divided by 4. Well, I say division is multiplication of the reciprocal. So multiplication of the reciprocal. Let's turn this division into multiplication then. And the reciprocal of 4 is 1 over 4. Well, now we're saying 12 times 1/4. Well, that's 3. Okay, so that's one way of thinking about it. Another thought is to recognize that this is 12 over 1 times 1 over 4. And then the rules of multiplication of fractions is to multiply the tops and multiply the bottoms. So that becomes 12 over 4, which is 3. Okay, so I hope that helps there. What about something like this? This also helps you in the concept of, what if I was going to take an expression like 6 divided by 1/2? Well, if you thought about the idea that division is multiplication of the reciprocal, well, then you could look at this expression like this. 6 times the reciprocal of 1/2 is 2 over 1. Well, then you would look at that and say, well, 6 is 6 over 1. And now I can go straight to my rules of multiplication of fractions. 6 times 2 is 12. 1 times 1 is 1. And so that just simply becomes 12. Okay? And so, and another way to be thinking about that is that that's saying 6 divided by 1/2. How many 1/2s do I have in 6? Well, for every 1, there's 2 1/2s, right? So I've got 2 halves times 6. 2 times 6 is 12. And so there's our few examples and a few ideas in simplifying and emphasizing this idea of GEMDAS. So we have a little bit of homework. I have a single sheet of order of operations for you, and I'd like for you to do that and submit that as part of the work for this week.